Welcome to this demonstration of the U2V methodology. I will be creating a Unity project and linking it to Vijeo Citect. There will be 4 parts in the building process and then finally testing. Imagine there is a plant, and this plant can be broken into 5 areas, each with its own Modicon PLC. This demonstration will focus on Area 3. Part of the process in Area 3 contains this equipment. For this demonstration, I will create the motor-operated valve and the VFD-operated pump. The pump control will be based on these requirements. I begin the demonstration with a Unity Pro project that only contains hardware configuration. This is a Quantum hot standby system with remote I/O on S908 and Ethernet I/O, 2 drops of Quantum. The only variables in the project exist because of the Ethernet I/O. I will export the project to a ZEF format. And then I will use the U2V DFB Mngr tool to create program sections for the motor-operated valve and the pump VFD. The DFBs include definitions for the Vijeo Citect alarms and trends, so note the alarm categories defined for Area 3. I will first create the DFB for the motor-operated valve. I will launch the U2V DFB Mngr tool and locate my motor-operated valve DFB. Here you can see an image of the DFB with the input and output variables. The DFB Mngr tool generated help file for the motor-operated valve shows the logic inside of the DFB. I have also customized the help to include the Vijeo Citect Genie and Super Genies that are associated with this DFB. I will now create a DFB template section instance. I will assign values to the template section instance substitution markers with the loop number and a description of the valve location. Here you can see the U2V parameters assigned to the DFB input and output variables. Next, I assign values to the public variables that are used with the DFB. This is where I'm using the alarm categories, and these will be assigned to the U2V parameters. This demonstration will not be using DMP3, so I will clear the DMP3 content. With the U2V parameter substitutions complete, I will now assign the variables to hardware I/O points in the Quantum system. I will load my Unity Pro project and select the Quantum remote I/O drop that is in the process area, and assign the motor-operated valve I/O points to the Quantum hardware. With all of the points assigned, I am done. And I will keep the Unity Pro project loaded as I still have to do the VFD. I will save the DFB section and move on to the VFD. The same steps will be repeated, and I will continue with the loaded Unity project. Again, I define the substitution markers for the loop number and the VFD description. I will be editing the public variables, which are linked to the U2V parameters for the variables on the input and output pins. And again, the MP3 is not used, so I will clear that content. The pump will have I/O in 2 locations, some I/O in the process area located near the pump, and others in the MCC room. So as I assign the I/O, I will assign it based on the location. Note the previously assigned valve I/O points are visible. With all of the points assigned, again, I am done. And this time I can close the Unity project and save the pump DFB section. I can now close my U2V DFB Mngr tool and go back to Unity and import the 2 sections just created. You can see that the sections came in, and you can see that all the variables have been created for both the valve and the VFD. Now we'll save the project and then export it again to the ZEF format for use with the U2V VJC Bldr tool. The next step is to create a new Vijeo Citect project. I will do this by using the U2V template to generate the new project. The U2V template project contains an include of the U2V include project, which contains the Vijeo Citect Genies, Super Genies, and SciCode. The Vijeo Citect driver that will be used is the OFSOPC driver. So the first thing I need to do is configure the OFS server. I will assign the PLC name, the IP address of the loopback, so we will use the Unity simulator for this, and use the data dictionary of the Unity PLC. I will save the configuration changes and save an archive file of the OFS configuration. The archive file will be used by the U2V VJC Bldr tool. Next, I will open the U2V VJC Bldr tool and use the utility, the OFSOPC Server Builder, to generate the Vijeo Citect servers. This is where I use the OFS archive file, and I select the Vijeo Citect project, enter a cluster name, the IP address of my computer, and generate the servers. Next, I use the Builder tool to generate the Vijeo Citect variables, alarms, and trends. I select my exported Unity Pro project, and then my Vijeo Citect project. And then I select the PLC from the Vijeo Citect server database, which was created by the OFS archive file. I will assign my alarm area descriptor for Area 3 alarms. Then I will process the tags. This reads the Unity Pro project, extracts the variable tags identified as being Vijeo Citect tags by use of the custom column, and assigns them into the application. I'm warned that comments are too long, and I can truncate those. The tool sees that variables are missing from the Vijeo Citect database, so I'm notified of those, what they are, and they will be generated into the Vijeo Citect database. Next, I will generate the alarm and trend tags. With the tag generation complete, I can now update the Vijeo Citect databases. Now I'm ready to start building graphics in Vijeo Citect. The first thing I'll do is grab the piping that I've already laid out in another graphic, just to save some time. Then I'll go into our new Vijeo Citect project and add a new page and paste the piping into that page. For this new page, I will use one of the U2V templates. With the piping in place, it's now time to add the valve. The valve genie name matches the valve DFB name. And the only entries required in order to link the valve genie to the valve DFB is the PLC name from OFS, the loop number, and the descriptor that goes inside the bubble on the valve. With the valve complete and in place, it's now time to go on to the VFD. Next, I will save the page. Next, I will go back to the U2V Builder tool and use the Menu Navigation Builder to create a menu that will allow me to navigate to the new page. I have to select the Vijeo Citect project, and the utility gives me the list of pages that are currently in the project. I'll create a new menu and then a menu item that will navigate to the page. Then I'll add a menu item to allow me to shut down Vijeo Citect. I will generate the menus and then update the Vijeo Citect project. Now I'll go back to Unity, build and load the application into the simulator. With the PLC application running, I can now return to Vijeo Citect and pack and compile the Vijeo Citect project. Next, I will run the computer setup wizard as this was a brand new application. And then I will run the Vijeo Citect project. Here you can see the navigation menu that was built, and it navigates to the page. Before we get into looking at everything in Vijeo Citect, I want to go back to Unity and add some simulation code so that my valve will modulate back and forth and my VFD will start and stop. The simulation code contains a DFB that modulates the valve, writing to the valve limit switches, and it also wires back the command to run the VFD back to the running of the VFD. Another thing that I want to do is to apply an interlock to the VFD so that if the valve is not open, the VFD will not run. I will build these changes and then go back to Vijeo Citect. Here you can see that I have communications and I have alarms. The valve is not in auto, so let me go back to Unity and force the valve into the auto mode. This has cleared my alarm, so when I acknowledge, it goes away. I can now open the valve, and with the valve simulation DFB, you see the valve travel. We also have an alarm that the VFD is not in auto, so I will go back to Unity and force the auto for the VFD. And note that that alarm is cleared from the banner. I can start the pump and then set a target runtime, which will also clear the other alarm. The final check that I will make is to test the interlock applied to the pump. So if the valve is closed while the pump is running, the pump should shut down. It does, and I get an interlock failure alarm for the pump. Thank you for taking your time to watch this demonstration of the U2V methodology and tools. I hope you find it valuable and time-saving. Subscribe to this channel to see more demonstrations of Unity Pro tools, tips, and tricks.